Hey guys, welcome back to my YouTube channel. And we are going to construct RAM8 using the given specifications. These specifications are from the course NAND to Tetris. So we have to devise RAM8 using memory of 8 registers, each of 16-bit wide. That means the data bits in the register is 16. Now the output holds the value stored at the memory location specified by the address. Here I will give you the inputs. So the inputs are given as follows. In is of 16 bits. The address is of 3 bits. There is a load of if nothing is mentioned, it is of 1 bit. So I'm going to remove that. Also, in the outputs, we have normal out 16-bit. So out holds the value stored at the memory location specified by the address. Now address lets us select which register to choose. So if address has 3 bits, so it can have 2 raised to the power 3, that is 8 combinations, so 000, 001, 010, and so on. You get the idea. Last is 111. So we have total 8 selections. So the word selections is here. So we have to use mux or demux. So let's proceed. If load is 1, then the in value is loaded into the memory location specified by address. So whenever there is an if condition, we must use demux or mux, a multiplexer to choose. Now the value will be emitted to out after next time step. So there is also a clock involved. So firstly, there is a demux demux involved, and here as you can see we have to use the 8-way demux. So 8-way demux, this will use the input, the selection is already the address, but input will be the load. So whenever whenever load is 1, the register will store value. So we can write if load is equal to 1, register number n will store. Now this n will be decided by the selections. So we have 8 selections. So n can be from 0 to 7. So we have 8 selections. Now after the demux, we have all the load bits. Now in will be load, selection will be the address, and inputs will be 8 because it is 8-way, and inputs will be in bit. Now registers will be containing normal in is equal to the in bit, and the load is the same and out is the same. Out will be, let's say, anything. After the registers, a mux 8-way 16 will be used. So we have 8 registers. 8 registers output will go into the mux, and mux will give an output of 16 bits. So we can write that. Now let's implement this using the program. Now I have made the circuit. The in bit is of 16 bits. Okay. The load is of 1 bit as specified. The address is of 3 bit. Now this is our output. This is our output of 16 bits. These are the clocks that I've set to real-time clock with frequency of 1 hertz. That means this will take every second, every second. So now when I run the program, if I give a value to, let's say, 5, and the load is Now on, off, and address is set to 000. 000 means the first demux first output. So let's see if we turn on the load. This turns on, this wire will turn on, and the output, as you can see, is 5. As you can see, the output is 5. But now, when I change the address, first let me stop the load, put the load to 0. When I change the address to, let's say, 2, okay. So as you can see, if I turn on the load, 1, 2, 3, this wire should get on. This gets on, and the output should remain 5. But if I change the output now, let's say 7. Okay, it changes to 7. So as you can see, whenever an output is shown, the RAM device stores that output regardless of whether the load is in, load is 1 or 0. So as you can see, this works. And this ends the RAM8. Thank you for watching.